let's first go over any types of questions that you may have. Let me grab one of the review sheets that I have over here. First off, everybody have their periodic table? Yes. And you guys know about the deal with the periodic table? Yes. All right. Good. Now, I don't care if you want to just throw questions out or if you want to go in order or anything like that. It doesn't matter to me. So, who's got questions for... Yes, sir. Oxyanions. What do you need to know about oxyanions? What are they? All right. An oxyanion is a polyatomic ion with oxygen. So if you see something like SO3, which I believe is 2 minus, this is considered an oxyanion or oxyanion because it has the oxygen in there. If there's any type of other anion that does not have oxygen in it, it is not an oxyion. So just think of oxy refers to oxygen. So it has to. It's an anion with oxygen in it. Did I clear that one up? Yes. I think I have a different review. Which number? 13. Oh, using isotope mass and abundance, how can you calculate mass of an element? Awesome question. This is, I got to find my book. That's not the book. This is going to be on the math portion, so this is going to be good for you to see. All right, where are you? All right, now let's just take an example. And so this is isotope mass and abundance. Because when mass is calculated, it takes into account all the different isotopes and when you get your atomic mass number. So we're calculating atomic mass. So we're going for atomic mass. Now, let's say that you have this table. And this is kind of like how the question on the test is going to be. You're going to be given, here's your isotope. And everybody remember what an isotope is? It's not different amount of protons. Because if it's a different amount of protons, the element will actually change. Because remember, what makes an element an element? not necessarily its number, but what particle, what subatomic particle? The proton. So you got to change something. And when you're dealing with isotopes, we're not changing electrons. We change electrons when we're talking about ions. We're losing, gaining, or sharing. So when we're talking about isotopes, we're talking about losing neutrons or gaining neutrons, whatever it is. All right. So let's say this is just fake. This is totally fake. So we have two isotopes, and the mass in AMUs, that's 6.015, and that's 7.016, and this is the percent abundance. Now, do we know what abundance means? Yeah, how much of the isotope do you actually have? And it says there's 7.5% of the first isotope, which is whatever this is, X with 6 up top. That's the first isotope, and then 92.5%. And if you add these up together, what should you get? If these two isotopes make up the element, it should add up to 100%, because that should cover the entire element itself. That you add that up, that's 100%. So it works out pretty good. Now, when we're doing the math, can we use 7.5%, or do we have to change it? Change it to what? Yeah, this is going to get changed to 0.075. So you're going to basically move the decimal twice. So I'm going to move the decimal twice here and get 0.925. And so now we have our mass, we have our abundance. Now, I'm going to throw a Greek letter at you that you're going to see more and more and more. So your atomic mass is going to be equal to, do you remember what this guy is? Sigma. And what does that mean? This means add up everything after the sigma. So we want to go mass times abundance. So we want to add up every single time for each isotope. So our atomic mass is actually going to be, you take the first guy, 6.015, and what am I going to multiply it by? Multiplied by its abundance. So I'm going to take this guy, multiply by this guy, and then I'm going to add up the mass, 7.016, times 0.925. And that should cover all, well, since there's only two isotopes, that'll cover both isotopes. And so I'll take 6.015 times 0.0715 in parentheses plus 7.016. I love parentheses times 0.925, and we get an atomic mass that's equal to 6.91987 AMUs. And then, but first off, does that make sense? You're going to take your mass, your AMU times the percent, then add on the next one times the percent. You could actually, if you wanted to, extend the table out and just go mass times percent, and then just add them all up and get an answer. If you like the table form a little bit better, It'll be this times this times this, and then you'll get your answer. And then when you have your atomic mass, you could actually go into the periodic table. It's 6.91987, and you look for 6.91987. This one's not the best one. But if you look at lithium, lithium's at 7. And helium's at 4. So I'm going to take a guess and say this guy's lithium. Because I think the bottom number is the atomic weight. And I think 6.91987 would get rounded to 7. Even though this is just the atomic weight, which is protons plus neutrons. I think that lithium would be our best bet in that case. Does that answer your question? Awesome. Yeah. Yeah. All right, more questions. The multiple choice stuff that you have on the test, it's asking you the very, very similar questions that have been asked on tests. Basically, do you know your stuff? The math portion, remember, the math side of it is going to be, you're going to get electron configuration, you're going to get orbital diagram, you're going to get a dot structure, you're going to get energy, E equals H times V, or energy is equal to H times C over lambda, and you're going to get the C equals lambda times nu, which is speed of light is wavelength times. This guy right there is wavelength. That guy over there is frequency. And that's in your EM spectrum. And abundance / atomic mass. So when we take the math portion of everything, that's what's going to be on there. So if that's going to focus you or any questions that you have. Yes. Oh, the rounding rules. I think you guys have different numbers than I do. Because you say it's number 5, it's number 4 on mine. No big deal. Now, rounding rules. When you multiply, all right, so what are the rounding rules when you multiply? For multiplication, it's going to be the smallest number of significant digits. When you're adding, it's just going to be what? Help me out here. Smallest number of decimals? Yep. The smallest number of decimals. So when we're doing our rounding, 5 we're going to round up. Anything 5 or greater we're going to round up. Anything less than 5 we're going to round down. What was the one rule that was really messed up with when it was 5-0? If it ended in 50, which way do we round it? Are you sure about that? Oh, yeah. If this number right here, if that number right there is even, we're going to keep it, right? If this number right here, if we're rounding to this number and it ends in 50, if it's even, keep it. If it's odd, what do we do? Round up. And I'll be honest, I looked, I couldn't find a reason why. So we're just going with it. And chances are, you probably won't see it. Just because it's weird and it like I said, it's weird. Everybody good with significant figures? If I have 0.0023, how many sig figs do I have? How many? 2. If I have 2.0137, 1, 2, 3, 4, 5. There's 5. If I went 5, 0, 0, 0, 1. Nice. You got it. The biggest thing is everything's significant unless the zeros are placeholders. Like, without these zeros, we wouldn't know it was 5,000. So, they're not significant. Without these zeros, we wouldn't know that it was tens, hundreds, thousands. We wouldn't know that it was 23 thousandths. So, we wouldn't know that that's where it was. But if I gave you this, 5001, how many sig figs do you have? 4. Because now that 1 takes it takes away that idea that it's a placeholder now and it's actually a number. And I'll be honest, I don't believe I have a single question on the midterm that actually says how many sig figs are in this or in that. So, and I don't think I have a question that says round this or round that. You guys did a nice job on it the first time through. And you guys do it all the time anyway, so. On the math part, you'll have all the equations. You'll have the equations and you'll have the constants. No, you can't. You're going in pretty much on your own. The only thing that you need to be able to do is know when to use a certain equation. Other questions? Yes. Which one's number 8? Okay. This is actually a good question. And I'll address atomic number, mass number. Atomic number is usually given as A. Now, mass number, if it's a variable, it's given as a Z. So, now, for an example, let's take fluorine. Fluorine, it has an atomic number which is equal to 9. And it has, on the periodic table that I have right now, it has a mass number which is equal to 19. So this would be A, and this would be Z. Now, a question that could be asked, what is the isotope form or the ZA form of fluorine? And all that is you take fluorine and you're going to put Z up top, the mass number, and you're going to put the atomic number down here. And what that does is, this says, all right, well, fluorine, it has a mass number of 19, and it has an atomic number of 9. So this is your atomic number, and this is your mass number. Now, here's what is going on here. Your mass number is equal to atomic number plus the number of neutrons. But what does the atomic number equal? The number of what? Protons. So you could say that the mass number is equal to protons plus neutrons. And that's why the mass number can change, is because if we go with different isotopes, you can end up with different types of mass numbers. So, if you take fluorine has a mass number of 19 and it has an atomic number of 9. So if I take fluorine and I say, how many protons does it have? So how many protons does it have? How many? 9. And that's, remember, its atomic number. And I might ask, how many neutrons? Now, what's the calculation you're going to do? Take the mass number minus the atomic number. So 19, which is your mass number, minus 9, which is your atomic number. And that's equal to 10. So I know that as written, this has 10 neutrons. Now, you could get, like for example, if you recall back to September when we were talking about isotopes and such, we were talking about hydrogen. Hydrogen had 3 of them. Now, how many protons are in each one? 1. This guy right here is always the number of protons. Now, when you see 3,1, this is an isotope. This is tritium. So, how many neutrons are in this hydrogen? 3 minus 1. You actually have to subtract off. Yeah, because the mass number, remember, is protons plus neutrons. So you subtract these two numbers, and you're going to get 2. This is 2 minus 1, which is 1. This is 1 minus 1, which is 0. So you get 2 neutrons, 1 neutron, 0 neutrons. So if you get the different isotopes, you can always figure out the number of protons because that's equal to the number in the bottom. The number of neutrons is equal to the number in the top.